Here we'll deal with Newton's law of cooling. Anytime you're asked about an object heated up to a high temperature, in this case 420 degrees Fahrenheit, and then placed inside of a room that's much cooler than that, you can use Newton's law of cooling. Now let's briefly go over what each of the letters mean in Newton's law of cooling. The big R represents the room temperature. If we look at the question, we're starting at 420 degrees Fahrenheit in the oven where we're baking the pizza. But when we take it out into a room, that room temperature is 75 degrees Fahrenheit. That will be our R. Now the I will be the initial temperature of whatever you're trying to cook. Since our oven was 420 degrees Fahrenheit, we'll let that be our initial temperature. Next, the lowercase k is the cooling constant of whatever object you're being asked about. This cooling constant will be different for every object, so we don't know what that is. And in fact, the question says, what is the cooling constant for the pizza? We don't know the cooling constant for this pizza, so we'll write that we don't know that, and we'll box that in our equation. This will be our unknown for this question. The T will be the time that is passed. In the third line in the question, we are told that after 10 minutes, we'll end up with a temperature of 120 degrees. Therefore, we'll let the T be 10 minutes. Finally, the Y. The Y is going to be our new temperature after the time has passed. That new temperature is 120 degrees. So we let 120 degrees be Y and let T be 10 minutes. Let's have a look at our equation and see which letters we know. We know R, we'll check that off. We also know I, we also know Y, and T, and K will be our only unknown in this question. Now let's place the letters in their positions, starting from the left and going right. The Y is 120. We'll set this equal to big R, which is 75, plus parentheses I minus R, which is 420 minus 75, multiplied by E to the K times T. The K will be unknown, but the time that is passed will be 10. So we'll write this as E to the 10K. Now we will subtract 420 minus 75 to simplify. If we do so, we will get 345. Our equation is now 120 equals 75 plus 345 e to the 10k. Our goal now is to isolate this exponential and eventually take a natural log of this. The reason why we would use natural log here is because the base is e. However, we can't take it yet. We have to isolate it first. Therefore, we will begin by subtracting 75 from both sides. This will get rid of the 75, and 120 minus 75 is 45. Set this equal to 345 e to the 10k. Then we'll divide both sides by 345. This will leave us with a fraction on the left. 45 over 345 equals e to the 10k. We'll move to the next page to simplify this. On this next page, we'll take ln on both sides. The left will now say ln of 45 over 345. On the right, we will have ln of e to the 10k. However, ln and a base e exponential are inverse functions. Since these are inverse functions, we can cross out ln and cross out the e and leave the 10k behind. This will give us ln of 45 over 345 is equal to 10k. Finally, we'll divide by 10. This means our k value is equal to ln of 45 over 345 all over 10. We can go to a calculator and simplify this. Our cooling constant is negative 0.204 if we round 3 decimal places. Once you've found the cooling constant, this can enable you to answer other questions about this object. We'll do an example of that on the next problem. This question uses the same pizza that we dealt with in the previous problem and the cooling constant that we found from the previous problem, and it asks, what temperature will you reach if you accidentally leave the pizza out for a full hour? With this in mind, we'll reset our Newton's law of cooling equation. We'll say y equals r plus I minus r times e to the kt. Let's have a look at the information in the problem. We have 420 degrees Fahrenheit for our initial baking temperature. This will be my I for initial. The room temperature that we're taking the pizza into is 75 degrees Fahrenheit. That will be our R. We're also given that we have a K of negative 0.204 from the previous problem, and we'll be leaving out the pizza for an hour. This will be our time. Now, bear in mind that this hour is 60 minutes. We have to use minutes because the equation we used is based on minutes. If your time was based on minutes in the previous question, you have to keep your time in minutes. So we can write that the time is 1 hour, but we must also note that that's the same as 60 minutes. This means we know K, we know T, and we know R, and we know I. Let's place all of those numbers into the equation. The R is 75, plus I minus R, which is 420, minus 75, times e to the k, which is 0.204, times t, which is 60. The only thing we don't know here is y, so we can place this entire expression into a calculator and end up with a number. The answer we get is almost exactly 75. This means if we leave the pizza out for an hour, the temperature will drop back down to about the temperature of the room, 75.00 degrees Fahrenheit. So this is how we can use a previously found cooling constant for an object to find other information about the object. Thank you for watching. We'll see you again soon.